Okay, here's the handheld dual trace meter that I got that I want to try checking out. And eventually I want to try to do a TV alignment. And what I'm going to do is I'm going to use this equipment for that. So I have a sweep generator, and I'm going to be using my old analog scope for that. And I've got it currently set up, so it's currently running. I've got it set up in the color band pass band right now. So there's the sweep. I can turn on the 3 markers within that frequency range, and there's what it looks like on here. Doesn't look too bad. I think I can do an alignment with this. I don't have it hooked up to a TV right now. It's just feeding straight through. So let's see what this other handheld meter can do with it. Okay, so I moved the cables over and I've got everything set up as well as I can. And here's what that same sweep looks like on this scope when I have the scope in XY mode. It looks like I can probably use this. I can adjust on my marker generator. I can increase and decrease the marker size and all that, and it looks like it probably could work. I still think I prefer my analog scope, but this probably could handle this. Let me try some other things on here. I can switch it over to XY mode, and here's what the X and Y signals look like. And if I use the auto ranging, I can get back to where I guess I originally started from. I did adjust the levels for the XY mode. If you go to auto ranging, this is what it's coming up with. Not too bad. And it's got various on-screen things you can add. See, there's this menu. You can change the menus along the bottom of the screen. So I can adjust the horizontal and vertical amplitude and things with the buttons. And if I come into this menus, there's a bunch of other things I can add. It can show various other things on the screen like frequency and things like that. So I can turn on and off various other things I want to see. Like if I step this down and push enter and then exit back out of this, now I have frequency displayed, and the sweep generator is running at 60 hertz, so you can see that it's not exactly staying on 60, but it's fairly close. So overall, it seems like it's not quite as nice as my analog scope in some ways, but it seems kind of usable. I'm going to try it later on more things like composite video and things like that and see what it can do with that. But it looks like even though I prefer my analog scope for an alignment, I could probably get by using this thing. Okay, I've set my sweep generator in the IF range, and I have the sweep width down to minimum, so it should not be sweeping. It should just be constant frequency, and with the width turned all the way down, looking at my scope, I appear to have about 24 megahertz if I count off the cycles here. I'm currently in my scope's fastest range of 50 nanoseconds per division. And if I increase the frequency, you can see that it increases in frequency, although you also notice the amplitude's decreasing, and that's actually because if I'm going to 50 megahertz, this is actually a 35 megahertz scope, so I'm kind of out of its frequency range. But if I count the cycles again here, I think that's getting up to about 44 megahertz. But if I look at this, no matter where I am in this range, I seem to have a reasonable sine wave, if I can believe that, because my scope is kind of being pushed to its limits here. And by the way, if I do add some sweep using the sweep control, you can see that it is sweeping, so the frequency is not constant anymore if I turn it up above minimum. Oh, and by the way, I think my scope should hopefully be fairly accurate. I have it hooked up right now to this scope calibrator with a period of 1 microsecond. So if I look at my scope with it set in the same 50 nanoseconds per division range, the entire 10 grid across is 500 nanoseconds, and I have exactly about a half a cycle in there, so 500 nanoseconds would be half the period of a 1 microsecond waveform, so it looks like my scope is fairly well calibrated. I can notice something else. If I'm in the IF frequency range at the low end, I think on my other scope it's set around 24 megahertz, and this is showing 25, and the wave looks pretty good. But as I increase the frequency, the waveform starts changing shape. And it ends up with this strange waveform that keeps increasing and decreasing in amplitude. Like maybe somehow the signal generator is beating against the sampling rate of the scope or something, because once I get close to what should be the maximum frequency of the scope, I start seeing instability, and it seems like it's because it's doing something like this. If I can change the vertical scale, maybe I can make it look different. Let's try a few more things with this, using my sweep generator again as a signal source. Right now I have it set on the low frequency range, which is where I had it before for the TV band. Oops, it's decided to go off. And it's showing a frequency of about 3.67 megahertz, period 2.273 nanoseconds, about 2.5 volts peak to peak. And that's with the sweep width set to minimum. If I turn that up, you can see the reaction to that. The scope seems to handle that fairly well now that it's sweeping different frequencies, but it stays synced in the center. And as I go back down to no sweep width, it goes stable again. Okay, here's something else kind of interesting about this scope. I have it hooked up right now to this port. The probe is hooked up to this port on the side, which is basically the calibration pin or a frequency generator output. And by default, it's generating a 1 kilohertz square wave. And I have this button, this option, fast Fourier transform. If I turn that on, that's basically a spectrum analyzer. So that red line that showed up when I turned that on is showing across the bottom in red. There's a peak on the left and a bunch of peaks over on the right. Those are the fundamental frequency on the left of 1 kilohertz and all the harmonics at 1 kilohertz intervals above that. So basically you have some kind of a spectrum analyzer here. I don't know what the horizontal scale is supposed to be because I don't see that shown anywhere really. But if I go to the frequency generator output, which has simpler functions for basically a calibrator when the scope is active, I can change that to, for example, a sine wave. If I exit out of that, now you notice that red line has only one peak on the left, because that's because with the sine wave there's no harmonics. And I can change it to a triangle wave. And you can see now that the red line has a couple harmonics, but a triangle wave is closer to a sine wave, so there's not as many harmonics as there are with a square wave. So that's kind of useful. It has almost like a built-in spectrum analyzer. And show you one more thing. You only have limited options of the signal generator output when you're using the scope. But if you go into these apps, there's a generate app, and this has more signal generator options. So you can generate sine waves or square waves, triangle, half full, or sawtooth. But in this one, you can turn it on and off, by the way. You can see the on and off at the top. But you have more frequency options in here, so I can run the frequency of the sine wave up to 344 kilohertz is the fastest. And I can't see that, by the way, on this built-in scope. I'd have to use my other scope to look at that. And if I go to square wave, that one will go up to 500 kilohertz. So the maximum frequency is actually different depending on which wave type you're generating. So basically you have a signal generator, but it's very limited. You can change the frequency And for square wave, you can change the duty cycle also. So it says you have a whole lot of different frequency, different waveform options, but a good number of them are just different duty cycles on the square wave. Plus the triangle, half wave and full wave. The half wave, by the way, I'll show you that. That just looks like that. And the full wave is basically a full wave rectified signal. So it can output that too. And the voltage is only 2.5 volts peak to peak. In this mode, you'd have no other options. So it generates nice waveforms if this is what you want, but it's still kind of limited. It can't modulate. It can't change its output level much at all. But for what it does it okay, but it's not really what you'd want for alignment purposes. The frequency range is too low. So you can't use it for AM alignment at all because you can't get to 455 megahertz or kilohertz, excuse me, at all with a sine wave. But in a square wave, it actually could. But if you look at the frequency options, you might like 455 kilohertz. But you can't actually get there. 434, 454, 476, there's no 455 option. So even if you try to use this and ignore the harmonics, you can't get to 455. So that's what it has for a signal generator. It's kind of okay, but it's not really adequate for what I'd like for service work. And finally, just for completeness, this also has a multimeter. So you can measure DC or AC volts. Ohms. This also has a continuity mode, a diode test mode, and a capacitance mode, and a couple of amp ranges. Milliamp ranges, and you get a warning when those pop up about connections. And it shows for most of these minimums and maximums, average. So it's actually not bad as a multimeter either.